Welcome student. Our today's topic is laws of absorption of light. In previous period, we come to know about the photochemical reaction and dark reaction and difference between them. Now see laws of absorption of light. Now when a beam of monochromatic light is allowed to pass through the homogeneous medium. Medium must be homogeneous. Means if we have homogeneous medium, let consider this is homogeneous solid medium. When light is allowed to pass through this or allowed to incident on this homogeneous medium, then there are three possibilities. Three processes takes place. Some light get reflected, some light get transmitted, and some light get absorbed. Means if suppose I is the intensity of monochromatic light which is allowed to fall on this homogeneous medium, then this intensity of incident light is I, that is equals to I A, that is intensity of absorbed light, plus IR, that is intensity of reflected light, plus IT, that is intensity of transmitted light. Means the light which is incident, that light get absorbed, some part get reflected, and remaining part get transmitted. That's why the intensity of incident light I is equals to IA plus IR plus IT. But for air glass medium, this IR, that is intensity of reflected light, is considered to be negligible. That's why it becomes zero. That's why I is equals to IR plus IT. Means IA plus IT. Means for air glass medium, that is for comparison cell, this I is equals to intensity of absorbed light plus intensity of transmitted light. Now, according to Pierre Bouguer, name of scientist, according to Pierre Bouguer scientist studied about the absorption of light when light fall on a medium of a particular thickness, and Bouguer investigated that the range of absorption of light with the thickness of the medium. But the study of this Pierre Bouguer extended by scientist Lambert, and Lambert used the solid homogeneous medium to study the law of absorption of light. And further, Beer comes forward, and that Beer's law is applicable to solutions only. Means the Pierre Bouguer investigated about the range of absorption of light by the homogeneous medium, but the study was extended firstly by Lambert's law, which is applicable to solid only, and second, that Lambert's law further extended by the Beers, and the study of absorption of light is applicable to solutions only. Now see Lambert's law. Now in this Lambert's law, the medium used is homogeneous solid medium. Let me consider this is homogeneous solid medium. Now in this Lambert's law, this medium is a solid, that's why here there is a uniform distribution of material. Means when light of intensity I is incident, and let me assume the thickness or width of this solid material is x, then for such a solid medium which having a thickness x and intensity of incident light is I, no doubt this intensity of light is I, that light is of monochromatic wavelength and this medium is homogeneous, particularly solid, then according to Lambert's law, when a beam of monochromatic light is incident on such a homogeneous medium, then there is a decrease in intensity of light with the thickness of the medium, and this decrease in the intensity of light with the thickness of the medium is directly proportional to the intensity of this incident light. Mathematically, decrease in the intensity, that's why di by dx is directly proportional to the intensity of incident light on this homogeneous solid medium. Again, further, this di by dx, this proportionality sign is removed, that's why it becomes is equals to. Now there is some constant, and that constant is called as K, denoted as a K, and this is called as absorption coefficient. What is it called? Absorption coefficient. And this is I. Now rearrange in order to solve like terms, that is here di, here I, that is I comes here, that's why di by I, that is equals to K into dx. Now integrate above equation. That is integration of di by I, here K constant, that's why integration of dx. Now further integration of di by I, it will be ln I, that is equals to K into x. If we put limits here, let me assume if the intensity of incident light is I0 and the intensity of this transmitted light is I, then it becomes I0 to I. Here this width of this homogeneous solid medium here is 0, then it becomes here x. That's why the lower limit is 0 and upper limit is x. Now after putting these limits, then it becomes I0 to I and it becomes 0 to x. Okay. Now further ln I, lower limit I0, upper limit I, that's why ln I upon I0, that is equals to K into x minus 0, that's why it will be x, that is ln I upon I0. Okay. Now after solving this further, Here, in the statement, we said that the decrease in the intensity of incident light with the thickness of the medium is directly proportional to the intensity of incident light. This decrease means there is a negative sign. That's why here there is a negative sign. Okay. Now, here there is a negative sign. We may take this negative sign here. Okay. Are you getting clear? समझ में आया ये? ln I upon I0, that is equals to minus kx. Now, if further we solve it, then taking antilog on both sides, that's why I upon I0, that is equals to minus kx. And here, antilog of I upon I0 is I upon ln I upon I0 is I upon I0, and here it becomes e raised to power minus kx. That is exponential law. Here I is equals to I0 into e raised to power minus kx, cross multiplication. This is Lambert's law actually. According to Lambert's law, the exponential decrease in the intensity of monochromatic light is due to the increase in the thickness of the absorbing medium. And if further we solve this, then suppose this is our equation 1. Now this is our equation 1, this is our equation 2. Now, if suppose this natural log is converted into log to the base 10, then this equation 1 becomes ln I upon I0. That's why 2.303 log to the base 10 I upon I0. That is equals to minus kx. Since this ln, that is natural log, is converted into log to the base 10, that's why multiplied by 2.303. Now further, log of I upon I0 is equals to minus k upon 2.303 into x. That is, log of I upon I0 is equals to epsilon x. Here, this epsilon is equals to minus k upon 2.303, and this epsilon is called as epsilon is called as extension coefficient. What is it called? Extension coefficient. Means Lambert's law, you know this statement, the decrease in the intensity of incident light with the thickness of the medium is directly proportional to the intensity of incident light. That is, I is equals to I0 into e raised to power minus kx, where k is absorption coefficient. After further solving, this law becomes log of I upon I0 is equals to epsilon x, where epsilon is the extension coefficient. In this way, this is Lambert's law for solid, that is Lambert's law for the absorption of light.